Hello, for today's lesson, we are going to discuss all about electric field, and at the end of the lesson, we can answer these following questions. What is an electric field lines, and electric field intensity? Now, let's start off by understanding electric field. It is an area or field around a charge where the electrostatic force can be experienced. We have here an illustrations. We have a positively charged object and a negatively charged object. Now, how could we represent this electric field to have a clear picture of what is going on? For that, we are going to use these electric field lines. If we have a positively charged object, the direction of the electric field is outward, and it is inward or going inside if we have a negatively charged object. The properties of these electric field lines, it indicates the strength and direction of the electric field. So it's either inward or outward. The more dense the lines, the stronger the field. The more lines are closer to each other, the stronger the field. It is directly proportional to the magnitude of the charge. If we have high magnitude of the charge, therefore we have also high magnitude of our electric field. It flows from positive source charge to negative source charge. So it always starts off with positive going negative direction. We have here an illustration, different cases. Observe the behavior of the electric fields if we have two objects having different charge. Positive, one is positive and the second one is negative. On the second illustration, we have here the same charge object, both are negative. Observe the behavior of their electric field lines. And on the third illustration, still we have the same charge, both are positive. It shows a repulsive behavior or reaction. Lastly, let's understand electric field intensity. Let's have an illustration. We have here a source charge denoted by capital letter Q, and we put a test charge denoted by small letter q. This positive charge will exert force on this test charge because it has entered the electric field of the charge object. Another test charge is placed and still we have the same reaction. Therefore, electric field intensity is the force experienced by unit charge in electric field. Now, for us to identify how strong the electric field is or the force experienced by this test charge in the electric field, we are going to use this formula. E is equals to F force over test charge. Small q is test charge, capital letter Q is represented as source charge. Now, if we are asked to compute the electric field intensity and the force is unknown, we could derive this formula to remember F is, to get the electric force, we have this formula 9 times 10 raised to the power of 9 QQ over R squared over Q. And let's derive this formula, simplify, get the reciprocal for us to multiply the denominator to our numerator, and we have this second formula if force is unknown. Solving time. Example number 1, a test charge of 20 microcoulomb experiences an electrostatic force of 0.4 newtons. Find the magnitude of electric field intensity. The given are Test charge, which is 20 microcoulomb, is equal to 20 times 10 raised to the power of negative 6 coulomb. We have the value of force, which is 0.4 newtons, and the unknown is E. Therefore, the formula to use is this one. Substitute the given. Force is 0.4 newtons and test charge is 20 times 10 raised to the power of negative 6 coulomb. Simplify the denominator and then get the quotient. Therefore, the final answer is 20,000 Newton per coulomb. Example number 2. How strong is the electric field at 10 centimeters form a 50 microcoulomb source charge? The given are the source charge, which is 50 microcoulomb, and that is equal to 50 times 10 raised to the power of negative 6 coulomb. And we have the second given is the distance, which is 10 centimeters. And take note, in the formula, it should be in meters. Therefore, let's convert 10 centimeters into meter. So we have 0.1 meter, and unknown is the magnitude. Observe the given. We don't have the value of the force. Therefore, we are going to use this formula. 9 times 10 raised to the power of 9 Newton meter squared per coulomb squared times Q over source charge or over R squared. Substitute the given we have here and then multiply 9 times 50, we have 450. Simplify 9 and their exponent, 9 and negative 6, that's 3 Newton meter squared per coulomb squared, coulomb, over 0.01 meters squared. In my previous recording, I discussed how we simplify these units, and coulomb will be cancelled out and meter squared will be cancelled out. What's left will be Newton per coulomb because it's coulomb squared. Simplify the numerator. We have 450,000 Newton per coulomb divided by 0.01. The result is 450 million Newton per coulomb, and that is our final answer. And that ends our lesson for today.